So remember we've defined now addition and multiplication in Zn, but I want us to kind of take a second and backtrack and think about integers for a moment and talk about properties that we have with integers. So there's several, and let's list out some of those properties. So for the first one, if I take two integers and add them together, it's still an integer. So this is called closure for addition. So the second property, so we're focusing on addition right now, is if I take a plus b plus c, it's the same thing as if I add a and b first plus c. So essentially what we do is we move parentheses. Remember, this is called associativity. You need to have an associative addition. The third property is that if I add a plus b together, it's the same thing as b plus a. So that means it's commutative, the addition. Four. This next property is if I add a plus 0, I get a, and it's the same thing as if I add 0 plus a. So 0 is your additive identity. When I add it to something, it keeps it the same. The fifth property, there's not a name for it, but for each a and the integers, the equation a plus x equals 0 has a solution in Z. So every element has what's called an additive inverse, a number when you add to it, you get 0. The sixth property, so now we're going to change talking about multiplication. So if I take two integers and multiply them, their product is an integer. This is closure for multiplication. The seventh one says if I take a times b times c, it's the same thing as a times b times c. Again, we just moved our parentheses. So this would be that our multiplication is associative multiplication. If I take a times b plus c, this is the same thing as ab plus ac. So you can distribute out the a. You can also distribute out on the back end. So if you have a plus c times c, this is ac plus bc. So these are called distributive laws. The ninth property for integers, when I multiply a times b, it's the same thing as b times a. That's that multiplication is commutative. Commutative multiplication. The 10th property is that a times 1 is a, which equals 1 times a. So this is an identity for multiplication. Multiplicative identity. And then finally, the last property is when we see a whole lot in we're solving equations in college algebra and calculus. If a product equals 0, then one of the two things has to be 0. So we might ask, the following question. These properties are all for integers, but which of these properties hold for Zn? And remember that the reason why we're comparing this is because we start with integers to get Zn, and our addition and multiplication are defined for Zn, are related to our addition and multiplication for Z. And so the answer to this question is that all of the properties hold except the last one, property 11. So what goes wrong with property 11? So you're going to have to look for a counterexample to show that it's not true. So my hint is to think about Z6, and you should have created the multiplication table in Z6. So if you look back at that, you'll see that if I take the equivalence class of 2 and multiply by the equivalence class of 3, you get the equivalence class of 6. The remainder, when I divide 6 by 6, is 0. So you are getting 0 here for the product, but the equivalence class of 2 is not equal to 0, and similarly, the equivalence class of 3 is not 0. So just because the product is 0 doesn't mean that one of your two numbers that you multiply has to be 0.